Émilie Pagé-Perron is an Assyriologist and a digital scholar. She is the very first junior research fellow in Assyriology at Wolfson College. Her research interests are Mesopotamian social history, Sumerian philology, and computational linguistics of cuneiform languages. Her doctoral dissertation discusses social identity in the third millennium through a study of the pantheon of the ancient city of Adab. And she employs both a traditional philological approach, as you've gathered, and computational methods in combination in her work, including data management and curation, natural language processing, and network analysis. And she is co-director of the Cuneiform Digital Library Initiative. Her presentation is called Digital Library Organization and
So hello, everyone, and thank you, Zizi, for inviting me to the workshop. I'm delighted to be here today. In this talk, I will briefly introduce the Cuneiform Digital Library Initiative and the data we curate. I'll discuss metadata organization, give a word about the related infrastructure to the metadata. Then we'll look into text and linguistic annotation formats, and then I'll be tying these questions back to open access. So the Cuneiform Digital Library Initiative, or CDLI in short, is a large-scale research infrastructure and domain knowledge digital library for the study of artifacts inscribed with cuneiform writing, and it's strong of 23 years of service now. These artifacts are from the Near East, centered around Iraq, and written using the cuneiform script, and they record texts written in multiple languages, among others Sumerian and Akkadian. And there are various genres, literary, administrative, scientific, etc. And they were produced during about 3 millennia before the Christian era. So it's a very large data set. So we estimate there are more than 500,000 artifacts inscribed with cuneiform in collections around the world. And these collections exist in major museums such as Yale Collection, the Louvre, the British Museum, and multiple others in smaller collections too. And more than 350,000 of these artifacts have been digitally documented at the CDLI. And 1/3 of these artifacts are imaged in our database. So we have at least one image of a third of the artifacts. This also represents 2.65 million transliterated lines of text. And actually, each time I show this slide, I have to up the numbers by a few thousand entries. So the CDLI is a scholarly cooperation with major partners at being UCLA, Oxford, and the Max Planck Institute for the History of Science in Berlin. The mission is to digitize, curate, preserve, and analyze the digital information about these sources, and this in the interest of open access and research. As essential research infrastructure in our field of study, Assyriology, our main objective is to preserve and share the data. So we offer the user a search function. We display the metadata image, which are, if available, in textual information about the artifacts. This is the current view for one artifact, but we're soon going to release a new version of our interface. It's going to look a bit like this. I don't have the full page right now because some of the sections are not fully working. We're hoping to release a beta version mid-December, a bit before Christmas. So looking at the metadata, which in our case is both about internal and external information related to the text, so the medium and also the text itself, for instance, artifact type, material, period, genre, etc. What has worked for us has been to prepare domain-specific metadata entities, because as a research database, our primary audience are the researchers, and we need the research community to be able to engage easily with the data. Additionally, in my mind, the metadata model has to live outside of software, where we can ask, for instance, questions like, can a text have more than one genre? Is there a hierarchical structure among materials? Can materials have colors? This is just like basic questions you can ask to organize the metadata in your mind. And so further looking at metadata entities as part of a network where entities and their relationship can have attributes, where we can model directionality and hierarchy, etc., can lead to this theoretical model that can't really exist because of technical limitations, but on which you can base yourself to create technical solutions based on your work. So of course, when conceptualizing a solution, we have to make practical and strategic decisions based on the needs and priorities. Often it's not possible to implement that whole model. It's also very important that categories and entities and their attributes are very well defined. First, because then the data is easier to reuse. And second, because then it's easier to match with external vocabularies, which is extremely important for sustainability and reusability. So we've been talking a bit about like funding and how projects cannot sustain themselves. Well, interface do die even if you have a project that lasts 30 years, but the data should sustain. So it's really important to share the data in formats that can be reused and live outside of these interfaces. So of course, technical solutions can vary according to the needs of the audiences, technical requirements, scale of the team, budget, other factors. We've heard some speakers talk about some of these. And we can use flat files, database tables, complex relational models, annotated data, graph database, etc. At the CDLI, we first start using a few flat tables that came from FileMaker, actually. We're still using FileMaker for the current CDLI. And those are also used in a relational model, those simple tables in their current website. Disadvantages of that, for instance, using free fields is prone to introducing errors like typos and other little problems. For each specific usage of data for some projects, it's harder to leverage a relationship between these data. So you need to write more elaborate algorithms to extract information from the metadata or the text or both. So for the new CDLI, we've adopted a complex relational model because we needed to leverage those relationships for accessibility of the interface in particular. Through browsing, and for other reasons we can discuss maybe at the questions period. So we still import and export data in a flat format, and this is for both for preservation. So if I export all my data in a flat format, then anybody can reinsert it in another model using just the field names. But also it makes the data easy to read for someone and to edit by a larger audience that's less technical. And we also provide web forms to lower the bar to access, to edit the data, for example. So we're constantly trying to improve our metadata. It's especially important as other projects depend on us for the metadata. And as part of the Uppsala Globe project, we're currently reviewing most of the metadata entities with groups of specialists, including Adam Anderson, who's going to present tomorrow, who's here right now. So in particular, we're dealing with provenances, chronology entities, and bibliography. Genres have been curated recently by a large group of scholars in France. And in Oxford, we've been working on artifact types with the Ashmolean Museum. We have matched all of our art history materials with the Getty Art and History vocabulary, and we're looking forward to linking with other entities as opportunities come in. Concerning the text, we store them in the database to facilitate search, so you can use regex and different fields where the information, for instance, of the structure or the text itself are separated to ease the search a bit. So ATF stands for ASCII Transliteration Format. It's the same format we've employed for, or almost the same format we've employed for the past 25 years. It encodes minimal metadata, so we can at least recognize the text and link it with the more complete metadata of the artifact in the database. It gives some structure about the text, also the transliteration lines, of course, and it can hold inline transcription and line-based translation. As a new addition to this CDLI, in the past few years, we've been working on implementing infrastructure for linguistic annotations. And so we have done this in the machine translation and automated analysis of cuneiform languages project. And so we did this in order to leverage and increase access to this collected data that we have at CDLI. And this for specialists with research objective, but also for a wider audience. So we decided to research state-of-the-art technology for the processing and translating of cuneiform languages in order to develop a reusable methodology in a pipeline using internationally established standards in terms of format for storage and sharing. And we're still working on integrating these technologies that we developed. We want to integrate most of them in a new framework, but they're all available as standalone software that you can get on GitHub if you're interested. Here's a list of all the contributors to the project. I can't name them all. There's so many now. Okay. So CDLI has attempted to adopt linguistic annotations in the past, and we also have sister projects that are really good at that, but that decided to use inline approaches, which we've tried. We also tried XML, but those were short-lived projects. Since 2016, we use a column-based annotation format, which is called the CDLI Connell. It's very close to the internationally shared standard Connell U, and we can easily convert from one to the other. And so we use our in-house Connell format to store exact structure information. So in Connell U, you can't put 0.1.3 for the ID. So in Connell U, it's just one and it goes down. Also, because the morphology, especially for Sumerian, is very complex. There's a lot of affixes. And so we, as Sumerologists, we need more information than what the Connell U can store for us. And so hope at some point we might be able to contribute changes to different ontologies that we use to store that information. But for now, we've used this, this version of the format so we can store this version of the way to store the data. Head and dipple columns are exactly the same as everybody's used to store syntactic data. I haven't filled it here. So manual annotators can work using plain text editor or a datasheet manager like Excel, just so the data is aligned by columns. Like if you have a lot of unequal data on it in a text file, it's a bit complicated. And we're working on implementing a simple text field and also table-based form for the web, just for quick editing. But we accept file upload, so someone can work on Excel and then send all of their files using a simple upload form. So the CDI corpus is non-finite and it's constantly changing. And as we discover new texts and understand some better, we do edit the data a lot. So all of our text formats, so both the annotation format, but also the ATF format, are meant to be easy to understand at a glance and modify quickly. So maybe annotating can be a bit of work. We have pre-annotators for that, but the goal is to be able to edit the data quickly and fix problems fast and just update the data online right away. And also our annotations are anchored in the text because the format we use is one token per line. So you know exactly which word has which annotations, basically. And this is, we hope in the future we can both leverage the context of a word and its attributes based on the other words that are close to it or in other texts, and also going towards the metadata. And the other way around is true too. So you could say, give me a list of words for that period, or those syntactic constructions for that genre. So we have set up a pipeline for manual annotation, as seen on this slide. Our automated annotation algorithms for morphology, syntax, transactional information, and translation are not shown here, but we're working on fine-tuning them for the automated pipeline. So this is all algorithms we need to implement into the framework so we can press a button and get the result. Of course, none of our algorithms are good enough to replace any of our manual annotators, but it's always a good head start. So if you get a translation that is partly good, it's much easier to go and to correct it than to write it from scratch. So our pipeline requires more than a few data converters, which actually we reuse also to provide the data in different formats for people to download. All of our, I said it already, I think all of our algorithms are available as standalone scripts. Most are written in Python, some in Java. All the data we can export in various formats, but it's also stored in the database, so we can quickly search it or use the MySQL to look into the data. It's also available for download through the interface. So for humans, they can choose what they want to download, and also through the API. The new CDLI search relies on Elasticsearch. The long search queries take about 10 times less time to process than before. So that's a great improvement for us. We're keeping the simple advanced search like the current CDLI. Although we've created combined fields like keywords and IDs, which provides searching across fields. And most simple search fields are also forgiving now. They're more fuzzy. So it's an easier entry point to get some data for people that are less experienced with the search. Um, so with the old or the current CDLI, if you want to if you want to find something, you often have to do 2 or 3 search queries to find how to enter your query in the proper way to get some results. So with the new framework, that doesn't happen. You always get results. So after searching, a user can filter the results further using the filter bar, which shows entities linked to the artifact present in the search results. These sort of search feature are standard in modern platforms now, but for us, it's really a great improvement, especially in terms of accessibility for collection curators, students. The students have a lot of problem knowing is this a museum number or publication number, and they just can't find what they're looking for. It's also a great way to improve the search workflow for scholars. Of course, providing textual annotations make it possible to visualize them, which we do through simple GS3 banking visualizations, nothing very fancy. So we convert data through RDF output, and it's possible to provide very powerful search across various linguistic features. Here, the format linked open data graph makes the approach possible. So we wanted to leverage the nature of the linked data for querying the texts and their annotations. So we built our own tool to that effect. So there's not so many consumers of linked open data to this day. So building new tools to be able to leverage that data hopefully will help develop the technologies in that direction. And so to that effect, we use the Sparkle server in the backend. We don't plan on opening the querying for the metadata on the Sparkle server. We've seen how difficult it has been with other projects, for instance, the feed at the British Museum and other places. So, we welcome anyone to download the data in linked format and reuse it in their own server or query the data in other ways. So we're offering it in cold, not in hot format or dynamic format. That's for the linked data. So, okay, so at the base of open access, there are the principles of the 5-star open data and also more recently the FAIR principles, which both kind of culminate into linked open data and using shared ontologies and vocabularies. So in order to adhere to these principles, we've mapped domain-specific linguistic information with the appropriate ontologies to share them in linked formats such as unimorph and universal dependencies. Our lexical data is linked to the EPSD, it's the dictionary that we have for Sumerian data in the field. We use the Ontolex ontology for that. So we've been like extending a lot our connection with the linguistic linked data in this project. And so we have also mapped most of our metadata entities using the CDOC CRM following the British Museum model, but we don't always use shared vocabularies to classify our information, but we're getting there. We're working on that. And so access is also a question of accessibility, I think. And so we offer data through the interface, but also using APIs, but not only as linked open data, but also in various other formats, which I was telling a bit about earlier. And we think this enhances sustainability, reusability, and access generally. And these data are available for a single artifact. If someone visits an artifact, they can download data for that specific artifact, or they can do a search and download the data for that specific search query. And also after doing filtering the data. It's also, we also have data dumps. So right now we have an ATF, so all the textual data and all the catalog data in flat formats are available in daily dumps. So anybody wants to have the latest data that we have at CDLI, it's available every day. With the new framework, we'll add the other formats, the other versions of the same data, but in different formats to be reused easily. So other ways to access the data can be useful for other audiences, especially when looking at the interface. So the current CDLI website doesn't have any way to browse through the data. And so when you have to do 3 searches to get to something, it can be really difficult to find anything, actually. We've decided to develop a browsing infrastructure for people to be able to get to the data in different ways, which they couldn't before. And so because all entries are now linked, it's possible now to navigate from one page to the other and discover information this way. So we can reach artifacts through any related entities such as genre, period, dynasty, region, provenance. Each entity type has an index, and some of them are a bit more involved. And from there, you can see an individual entity with its description and then go to an artifact from the search based on that specific entity. And then when you look at your artifact, all of the different entities are also highlighted. You can just click on them and go visit that page. And so you can basically run in circles and visit everything without having to search. Other tools are point of entries based on the different audiences and their specific needs, such as, for instance, as a score of witnesses for composite texts. We have them for all the composites. They just generated dynamically now. It's also possible to search directly into bibliographic data. And we also have, for instance, artifact filtering based on geographic heat map. So if you zoom in, you'll see only the artifacts that are in that region, and then you can filter through per other criteria. So for instance, a jar and other ways like that. So we have been slow at adopting certain technologies because our main mission is to sustain an essential service for scholars in our field. So we've been running for more than 20 years. So each edition needs to be useful on the long term, maintainable and sustainable, or we should be able to roll it out or off. I don't if we don't need it anymore. So at this time, we're fully focused on finalizing the new framework for which we expect the release of a public beta before Christmas. And there's remaining standalone tools to integrate into the framework. We're also finalizing the outputs of the MTAC project. So generated part of speech and named entities data, syntax annotations and translations. We have to check those and integrate them into the corpus. And that for around 73,000 texts. That's all the OR3, that's a specific period material that we have that we've been working on. And with the linguistic data we have collected, we're preparing manual and automated annotations. So we can now create entities for lemata and sentences and start thinking of offering lexical resources on the CDLI website. So we're developing preliminary infrastructure to this effect following the OntoLex ontology model. And finally, we're looking into implementing visualization of annotation of images. So signs can be marked and matched with the transliteration. So probably just C Dragon, but without IIIF for now. And it's just a mean to visualize these annotations, not edit them or add new ones. But this is what we'd like to do like in the short term. So that is it. Thank you.